Microcontroller 8051 Interview Questions. Questions 1. What is the 8051 microcontroller? One of the most widely used general-purpose microcontrollers today is the Intel 8051. It is a family of 8-bit microcontrollers created by Intel in 1981. Because it features 128 bytes of RAM, 4 kilobytes of ROM, 2 timers, 1 serial port, and 4 ports on a single chip, this microcontroller is sometimes known as a system on a chip. The 8051 microcontroller enables the CPU to process 8 bits of data simultaneously. If the data is larger than 8 bits, it must be divided into smaller chunks so that the CPU can handle it easily. Questions 2. What are registers in the microcontroller? The register gives processors and microcontrollers a quick means to gather and store data. To conduct operations like addition, subtraction, and other data manipulation activities with a controller or processor, we need registers to process and store the data. We cannot perform these operations directly in memory. The various register types found in microcontrollers can be categorized according to their contents or the instructions that use them. Questions 3. Why is 8051 called 8-bit microcontroller? Most possible operations on the Intel 8051 are 8-bit operations just because it is an 8-bit microcontroller. Questions 4. What is the width of the address bus? The width of the address bus is 16 bits. Questions 5. What are the types of interrupts in 8051? Following other types of interrupts in 8051, external interrupt 0, i.e. 0, has the highest priority among interrupts. Timer interrupt 0, TF0. External interrupt 1, i.e. 1 timer interrupt 1, TF1, has the lowest priority among other interrupts. Serial port interrupt. Reset. Question 6. What are the 4 distinct types of memory in 8051? Internal RAM special function registers program memory, external data memory. Question 7. 8051 was developed using which technology? The MCS 51 family from Intel was initially created using NMOS technology, but later iterations, denoted by a letter C in their designation, employed CMOS technology and used less power than their NMOS forebears. They become more appropriate for battery-powered devices as a result. Questions 8. What is the difference between bit addressable and byte address in microcontroller 8051? When data is stored in microcontroller registers and may be changed bit by bit, the register is said to be a bit addressable, 0 by 20 to 2F. The other is called byte addressable, as it manipulates data bytes at a time. GPR register is a byte addressable. Questions 9. Explain what real-time embedded systems are. Computer systems that monitor, react to, or control an external environment are known as real-time embedded systems. Actuators, sensors, and input-output interfaces link this environment to the computer system. Questions 10. Explain Harvard architecture microcontroller. The Harvard architecture-based microcontroller has physically separate memory storage for program code, instructions, and data, which are referred to as the program memory and the data memory, respectively. As a result, they have separate bus lines and can be accessed at the same time. As a result, the Harvard architecture-based microcontroller can execute instructions in a single machine cycle. The complexity of the microcontroller design and the development cost increased due to the two physically separate bus lines. They are most commonly found in modern microcontrollers and digital signal processing units. Questions 11. What is the difference between Harvard architecture and von Neumann architecture? The Harvard mark is the source of the name Harvard architecture. Harvard architecture's physical separation of signals and storage for code and data memory is its glaring feature. Program memory and data memory can both be accessed simultaneously. Data memory is often read-write, but code or program memory is typically read-only. As a result, the program itself cannot alter the contents of the program. John von Neumann, a mathematician and pioneer in the field of computing, is the name of the von Neumann architecture. Von Neumann machines communicate signals and have shared data and code memory. Since the program is kept in read-write memory, it may readily be changed by itself. Questions 12. Which bit of the flag register is set when output overflows to the sign bit? When output flows to the sign bit, the second bit of the flag register is set. The overflow flag is another name for this flag. In this case, the signed number operations output is too big to fit 7 bits. The MSB is used for signed numbers to specify whether the number is positive or negative. It is solely applied to signed number operations mistake detection. Question 13. Explain J and C. This instruction jumps if there isn't a carry following an arithmetic operation. If there is no carry, it is referred to as a leap, conditional jump instruction. In this case, a choice is made using the carry flag bit in the PSW register. The processor checks to see if the carry flag is raised or not. Question 14. Mention what the difference between a microprocessor and a microcontroller is. The microcontroller has integrated I/O, memory, etc., and was expressly created for control, whereas the microprocessor manages resources, I/O, memory, outside its architecture. Question 15. Explain what interrupt latency is. How can you reduce it? The amount of time needed to return from the interrupt service procedure after addressing a particular interrupt is known as interrupt latency. It is possible to decrease interrupt latency by developing small Lisp functions. Question 16. Why is an infinite loop necessary in embedded systems, please? Infinite loops are necessary for embedded systems to continually process or check the program status. A program state might, for instance, be checked constantly for any unusual mistakes that might only occur at runtime, such as memory outages or dividing by zero, etc. Question 17. Explain what is semaphore. In a concurrent system, such as a multiprogramming operating system, a semaphore is an abstract data type or variable used to manage access by numerous processes to a shared resource. There are typically two uses for semaphores: to share a common memory space, to share access to files. Question 18. What does addressable deal with? Physical addresses are the focus of addresses. During data transfer, it is a device that directly drives the data in address bus. Therefore, it is only a physical address. Today's question is over.